On page 8, we're going to get started with substitution, the second method. Last class we did graphing, now we're going to do substitution. These are the steps for substitution, so I want you to go ahead and write all these down. I know you wrote down a description for what the method is on page 2 of your packet. However, this goes through the steps and the specific details to take so that you can solve this correctly. Go ahead and pause the video. We're going to get started on problem number 1. So if you notice, step 1 is make sure that they're in slope, step 1 is to make sure that one of the variables is isolated. Well, both of them are isolated, right? For the first equation, y is isolated, and the second equation, y is isolated. Well, if I'm saying that y is equal to all of this, then that means this same y is also equal to all of this. So I can rewrite it as, and take this, 4x minus 1, right, instead of writing y, and I'm going to put equals 2x minus 5. I literally took this and substituted in for y, so my new equation looks like this. My goal, basically, by substituting is to make sure there's only one variable in the equation. If you notice, the only variable in this equation is x. So now I can actually solve by getting all variables on one side and then constants on the other. I'm going to add 1. And then I'm going to take my final step by isolating the variable that's left. So in this case, x is equal to -2. Just like in graphing where the lines intersect, right, unless it was a no solution or infinitely many solutions, you're looking for a coordinate point. I just found my x part of my coordinate point. That's the first part of substitution. But I now have to substitute again to figure out what my y is. I can choose the first equation or the second equation. It does not matter. I'm just going to choose the first one because it's easier. So I have y equals 4x minus 1. So since I think x is -2, right, I'm going to substitute that back in for x. So now I'm literally solving for y, right? I'm going to follow my order of operations. I get -8 minus 1, and therefore y equals -9. So I found my second part of my coordinate. That means my final answer is -2, -9. However, this is not always going to be the case where the substitution is set up nicely. Go ahead and turn to page 9. When the substitution isn't set up nicely, right, go back to your rules. It says step 1, isolate one of the variables. So that means I have to take a look at this. I want to isolate either this one or this one, or I can isolate this one or this one. There's always going to be one that's easier. In this case, looking at this equation, isolating the x is easier because there's no coefficient in front of the x. So that dividing step doesn't need to happen. So I'm going to change this and I get x equals, I'm going to add 4y to both sides, right, so that I can isolate it. And so I get positive 4y minus 18. Now I'm going to take this x, substitute in the other equation. The reason I'm using the other equation now is because I didn't change that one. I isolated my x, which is 4y minus 18, and I'm plugging it into the other equation. Because now look, if I get rid of all the distraction, I'm just dealing with this, and there's only one variable left, so I can distribute and solve for it. I get -12y plus, let's do 18 times 3, which is a positive. Oh, that is not 44. Sorry about that. It should be a 54. And then I bring my add 2y down. But I still need to combine like terms. So -12 and positive 2y gives me a -10y. Bring everything down. I'm going to subtract 54 on both sides, right? So I can, again, isolate my variable y. So I get -10y equals -50. Then I take my final steps. I'm going to divide by negative 10. And y equals 5. So if you notice, this time since we solved for y first, well, then I just got my y coordinate, right? Because it's x comma y. I still have to go back and substitute this. I'm just going to pick the first equation because for me it's simpler. Negative 3x plus 2y equals 4. Oops. So you have negative 3x plus 2, but that y is what is 5 equals 4. Now I can solve for x. Always be careful what you're solving for, because if you, for some reason, you plug it into the x, you're not going to get the correct answer. So be very, very careful. So as we solve for x, we're subtracting 10. So I get negative 3x equals negative 6, and then I'm going to divide by negative 3. And so I get x equals 2. I just found the first part of it. You can go ahead and practice with these two pages, with page 8 and page 9, where it's set up for you versus when it is not. Because one more instance is when you can get all real numbers or no solution on page 10. I'm going to have you copy down on page 10 problem number 3, 4, and these rules. These rules, again, are nothing different from our equations we had before. You take a look at the final answer. Is this statement true? No, it's a no solution. Is this statement true? Yes, it's infinitely many solutions. What it means is that the variables are all gone. When you look at this, when you go ahead and substitute, see in red, the variables go away. So then I'm left with just a number equals a number. I have to figure out, does that number actually equal it? Yes. So that means your solutions are infinite. No, that means it's a no solution. So be very careful as you practice these. And again, if you need to rewind, go ahead and rewind and pause so you have your set of notes here for page 10. Go ahead and continue to practice this lesson.